Welcome everybody. Good afternoon, maybe good evening or good morning on our, 49th webinar. And today, well, once again, we have Tobias Fenster as our speaker. Welcome to the show again, Tobias. Glad to have you on. Tobias will talk about applied infrastructure as code, deploying Business Central in an Azure Container Instance, a very niche kind of thing, but glad to see that we have an audience that's interested for your story, Tobias. But that's what you said at the start. I have a topic. Are you interested? Although it might be a very specific one, but I think this, while our community is getting more and more in using containers and trying to find a way to deploy it in a bigger context, whatever, I think it makes sense to do this anyway. So welcome, Tobi. I leave it to you to give a little bit more introduction for today. I guess a lot of you know Tobias already. I'm Luc van Vugt. I'm your moderator for today. You might know the housekeeping rules. Your microphone is always muted. You cannot unmute it. If you have any questions, and please feel free to do so. Tobi said that probably he has not the full hour needed to tell a story. So if you have questions, don't hesitate. We'll take time for that, and I'll pick them up and post them to Tobi. We agreed that I will pick them up more or less instantly. So yes, we got to the 700. Mohana subscribed to our channel, and we have 700 subscribers, so that's a great number. This will be recorded. It is already running, and probably already somewhere at the start of the evening it will be online. So feel free to use it, to share it, whatever fits your needs. If you are not yet subscribed to our newsletter, use this URL. You also can find the URL on our website, so be welcome to do so. There will be a new newsletter coming out somewhere next week or in the next week to come. 2 webinars already have been planned. A third one, two have been planned. The third one I'm working on with Henrik. Let me not say anything because that leaves room to him to really define what he's going to discuss. But 3 webinars ahead, and I'm working on some others before, well, we go on holidays for the summer. So, and yes, as always, you're welcome to join in with a topic suggestion or being a speaker yourself. So let me know if you want to. And before I'm going to hand off to you, Tobi, thanks to our sponsor, ForNav, every time again providing us the possibility to do this. So, Tobi, I'm going to make you presenter, and that leaves the task to you to share your screen.
Yes, I'll do that.
Yeah, it's in view.
Okay, great. So yeah, thanks for having me on the show again. I'm very happy to, as you said, present a bit of a niche topic. Also happy to see that a couple of people are actually interested in that niche topic. And also, as Luc said, please feel free to interrupt and let me know when you have any questions. To first of all introduce myself, my name is Tobias Fenster. I'm the one of the managing partners at 4PS Germany, a company that was founded just in January this year. I've been working in the Business Central ecosystem for more than 10 years by now. I'm a Microsoft Regional Director and an MVP for Azure and Business Central as well. And if you want to follow what I'm doing, typically topics related to Business Central, technology, Docker, containers, Azure DevOps, so more on the technical side of things, then Tobias Fenster is my handle on Twitter and on LinkedIn, and the blog URL where I typically try to put in some technical content once a month is tobiasfenster.io. So the topic for today is infrastructure as code. And what I want to do is to first give you an introduction, give you an idea and a plan what infrastructure as code is. We will focus on a specific tool that is called Bicep, and I'll share more with you on that as well. My idea for this topic, as I said, because it's kind of niche, is that I start more or less from scratch I hope I'm not boring too many of you who already know. I hope the demos will still be interesting for those who have more knowledge. But even if you have no knowledge at all of the topic, I hope that you can still follow the ideas and get a chance to understand what this is about and whether this might be interesting for you or not. Then after the more general introduction, I will show you how we can use Azure Container Instances for Business Central. So this is basically one specific example how you can use infrastructure as code with Bicep. And in the end, I will also give you a brief overview of other options instead of Bicep that you also might read about online or might consider to use if you don't like the Bicep approach. So let's get started on infrastructure as code. First of all, what is this about and why should you care? We already have enough solutions without matching problems. That is something that I see a lot of the time when looking at the technical infrastructure space. Azure services are popping up left and right. You have so many things out there, so many concepts, so many ideas. So why should you care about infrastructure as code at all? And I've described here what the problem is that infrastructure as code is trying to solve. Maybe this is something that is relevant for you. Maybe this is something that's not relevant for you. Then maybe it becomes relevant in the future. Now, what I'm seeing is that infrastructure is growing more complex in Azure specifically. So with the advent of SaaS, on the one hand, you lose all the infrastructure problems that you had on-premise, but maybe you're still running them on-premise or you're running them in an Azure environment. But also there are new things like Azure Functions, like Logic Apps, like maybe having an Azure SQL Server somewhere in Azure, or connecting services, having some microservice that is running anywhere, or Docker hosts or whatever. So while there is the SaaS story, I still see or can get feedback from my perspective that we still have a lot of infrastructure to handle. And doing this manually just takes too long and is too error prone. While maybe some of you are quite good at doing this, maybe some of you are starters in that area, but doing it manually time and time again, that is just too time consuming and you make too many errors by doing it manually. And at the same time, because of that, larger teams are working on infrastructure. So it's no longer just one person or two people, but instead it's really larger teams and they need to align and have an idea what each other is doing. Then we have the problem that infrastructure changes are happening over time and you need to understand what has happened. So the classical problem is on Monday, it doesn't work anymore. So what changed last Friday? And you might have to go back to the configuration of last Friday because you know that it has worked. Then we have the problem that development and operation teams, and with operations, I mean the teams that are creating the infrastructure for the software, they need to work together more closely, which basically is why the term DevOps was invented. And there are a lot of meanings to that. But one of them is that development and operations need to work closely together. But while the idea probably makes sense to a lot of you, the question is, how can you do that? And the last thing that plays into the infrastructure as code mindset is that if you want to create new infrastructure, that needs to happen very, very quickly. If you want to do maintenance, that must be done almost without any interruption, and it should need as little human interaction as possible. Because again, if you do anything else than an approval, then chances are that you will mess up at some point. No matter how good you are, no matter how experienced you are, manual will just create problems at some point of time. So that is basically the problem that we're trying to solve with infrastructure as code. And if you look at that, then it might sound like a familiar problem. We have growing complexity, we need to work in teams, we need to track changes. That is basically the story how development has changed over the last couple of years for the Business Central environment. And also that is the thing that has happened over the last decades for developers basically everywhere. It's in a lot of times no longer possible that one person is solving all the problems, but instead it's getting more complex. You need to work in a team and you need to track changes. So the way that development has solved those problems is also the same way that you can solve it for infrastructure. And that's where the name is coming from, infrastructure as code, which is the idea that the same principles, the same ideas that we're applying when we're working with code, when we're developing, we're also applying for infrastructure, which means that we want to have source control management, including version control. It means that we want to do changes through pull requests, and we want to do automated builds and automated tests. So basically, the idea is treat your infrastructure as code. And what that means is that we need to put our infrastructure into files, and we need to describe in files what we want to do. And there are two different approaches for that. My preferred flavor is declarative infrastructure as code, which means that you describe what you want, not how you get there. Basically, what you can do is either declare the result, and I'll show you in a second how that works, or you can create a bunch of PowerShell or other scripts that are basically describing how you get there. So I want to create a VM by doing some backend call, then I do this configuration, I do that configuration, and so on. That's the PowerShell way, where you describe how you get to the goal. But for the declarative IaC, the idea is to describe the end result and let the tool and the infrastructure figure out how it works. So basically, what an infrastructure as code, a declarative infrastructure as code file would look like is something like this. And this is, of course, pseudocode, so that's not how it actually looks like. And we'll take a look into the actual code in a second. But the idea is to just say, I need a VM. I need a VM with 4 CPU cores and 8 GB of memory, some storage, a specific Windows Server version. I want to have containers enabled and Docker installed. So that basically describes my VM. Then I can also describe that I want to have a firewall with 2 specific ports open for HTTPS and for SSH. And then I also let the tool know that I want to connect the firewall to the VM. And with that description, I have the explanation of what I want to do, what I want to set up, so that then the tool can worry about making that happen. So I only would describe this and put it into the tool, and then the tool would figure out which resources it needs to create, how it needs to create them, which versions, and so on. So I don't need to worry about all the details. I only need to worry about declaring the end result. In our example, I would say I want to have an Azure Container Instance with 2 CPU cores, 4 GB of memories in North Europe with a given DNS name, and the Business Central version should be, for example, the latest German sandbox. So basically, all I would define is the resources, the location, and which version of BC I want to use. And again, the rest should be automatically handled by the tool so that I, as a DevOps professional or someone who wants to deploy that environment, doesn't need to worry about. And that is the basic idea. And the tool that I want to introduce you today for using this is Bicep. Bicep is an infrastructure as code tool that is native to Azure. So that means that it can only handle Azure. You can't do Amazon Web Services, you can't do Google Cloud, you can't do anything else with it. And that might be a limitation for some of you that are not 100% Microsoft or Azure focused on that part. But it also ensures that we have quick and comprehensive support for Azure services. So basically, whenever a new service is popping up or when a new feature is popping up in an existing service, then it automatically or very quickly is available in Bicep. It has a very simple syntax, as you will see in a second. It very much looks like JSON that you might have seen in other contexts, but actually it's even shorter. We have very good support in Visual Studio Code through an extension, and we will also take a look at that as well. It allows to do repeatable deployments. So if you just run the same file again, and if nothing has changed, then it will just do nothing. And if a change has happened, then it's basically going back to the original state. And it has auto-managed orchestration, which means that if we have an environment where we have some dependency, again, the example of the firewall and the VM, if we need to configure the firewall after the VM, then Bicep will automatically pick that up and first create the VM and then create the firewall and in the end connect the steps. You don't need to worry about those kind of dependencies. It's just happening automatically. Then for more complex environments, you can also create modules to hide some of the complexities. And you can do what-if deployments. That means that you can just run a deployment and say, okay, if I ran this now, what would happen? And then you can get a result, maybe get an error already that shows you that you don't have enough resources or something like this. So it basically gives you the option to do a try run and find out what would happen if you ran this and fix any errors in advance that you might see. It doesn't have a separate state file. That is something that other infrastructure as code tools are doing. They are storing the state locally and then are syncing it with whatever is happening in the cloud. But that has benefits and drawbacks. That would be a bit too complex for today. Just when you look into other tools and you come across this, then you will see that this is a big difference between Bicep and other tools. It is free, comes at no cost, and is open source, so you can always take a look of what is actually happening. And at least in my opinion, the documentation about Bicep is very good. I've put the link here, and we can also put that next to the recording in the end, so you can take a look if you want that. So the first demo that I want to do with you is that I want to create a virtual machine, because that is something that I guess most of you can imagine. You need to provision a new virtual machine somewhere in Azure. It needs to run some scripts on startup to make it work. And what we want to do is we want to use the Azure Cloud Shell so we don't have any local dependencies. But instead of saying a lot more about it, I want to jump right into the demo. And you should see Visual Studio Code here. Just to get you oriented, what we have here is a Azure Quick Start template repository. What we have here is, as you can see, the Azure Quick Start templates repository. And the reason for that is that the two examples that I want to show today, I've also contributed into the Azure Quick Start templates. So you can just give it a try for yourself by searching for the Azure Quick Start templates, and we will also do that in a second so you can see where you can find them. The first thing that I want to show you is the Bicep file for a Windows VM. So you can see that here. And first of all, we have parameters, as you can see here, and they always have a description so you know what it is. So in this specific case, it's the account name for the storage account. And you can see here that I have a prefix, and then I'm creating a unique string, basically a random generated string that is based on the resource group. So we have something that's unique. The same here for a DNS label, again, a string with a prefix and then something random. Those parameters do have default values. I can override them, but they also have default values, as you've seen here. But then we have other parameters like the admin user that has no default value. That means that we need to enter them when we want to apply this specific template. The admin password here, you can see, is also random generated, but I can also override it. The public SSH key is something that I need to provide, and so on and so on. So we basically have a bunch of parameters, and then we have some parameters that have only specific selections allowed. So for the version of Windows, I can only have a couple of distinct settings. Same for a data disk that is attached. I only have a couple of default settings. And so on. Then next to parameters, we can have variables. Those you can see here. And I'll make that a bit smaller so you can actually see a bit more. So in that case, this is a URL that is generated. And the difference between a parameter and a variable is that a variable is something that you can't change when you're applying the template. So this is basically just internally, whereas a parameter is something that can be changed by the user who is applying the template. Now we have all the parameters and variables in place. The last thing that we need is the actual resources, so the Azure services, if you want, that we want to use. There we, for example, have a storage account that is in a specific location, has a specific name, has a specific SKU, so the type basically, and it can have tags and so on. We have a public IP address. We have a network security group. You can see here that we are blocking RDP access by having it denied here, and we are allowing SSH access on port 22. Again, just to give you an idea how that setup works, you can easily read it if you're familiar with how those resources work in the Azure portal or have seen them created, then you will recognize the settings here. We have a virtual network that we need to set up. We have a network interface that we need to connect to the public IP. You can see here how we are referencing other things. So the public IP here is pointing at the public IP resource that we have created here. So it's also very easy to reference the resources one from the other. Then we have a data disk, and then we have the actual virtual machine that you can see here. And that has all the settings that we've defined above, the size, the admin user, the password, the storage account, and so on. So everything is connected here. And then it's also running a specific setup script, which is doing initialization and is creating SSH access for us. And then in the end, we can also have an output. And that output is showing us how we can connect to that particular virtual machine. So it uses the admin user and it uses the domain name that is generated for us to generate that string. Okay, now that we have that script, how do we apply it? How do we actually create that virtual machine? And the easiest way for this is, as I will show you in a second, to connect to an Azure Cloud Shell, because that one has all the required tools already installed. So nothing additional that we need to do. And we should be connected in a second. Let's create a folder for the VM. Then we need our Bicep file. We can easily upload that through VS Code and then move it into doesn't want to autocomplete, but I hope this works. No. Upload to Cloud Shell. Uploading. Need that a bit bigger. Oh. It doesn't want to upload. Let's try to do a quick reload. Close that one. Try again if it would let me. Yeah, now it's connecting again. Let me activate the screencast mode so you can better see what I'm doing. Try to upload the file again. And it says uploading. Yeah, now it's uploaded. And move that file into the folder. So now we have uploaded that template. I'm again just doing it so I don't have to install any tools locally. And then we will create a resource group, which is kind of a folder for infrastructure in Azure. And that one, as you can see here, was successfully created. And as a last step, we will create the actual deployment. Just copy and paste that. Oh, didn't want to copy. Yeah, now it has copied. So if we go back in here and remember the parameters that we had, two of those parameters were the SSH key, and you can see here, and the other parameter was the artifact location, you can see here. And if we look at the command that we created, we have those parameters here. So that is one option how we can provide the values, basically with the SSH key here and the artifact location here. But if we don't provide a parameter, then Bicep will automatically ask us, because if you again remember, we had the admin user here, and that doesn't have a default value. So we need a value to be able to deploy this. And Bicep has automatically recognized that we don't have a default value, so it's asking us for that user. So let's go. Bad idea. Try again. So let's use admin for that. And now it says starting and the deployment has started. If I now go to the Azure portal, go back here, and sign in. In the resource groups, we should see a new one that we just created. You can see here, Areopa VM. That was the one that we just created. And we can see that a deployment is happening and it has failed. Let's see why it has failed. Okay. Yeah, admin is not allowed. So let's just try again. So let's try VM admin. And by the way, you can see the error message here above as well. The admin username specified is not allowed. So I don't need to go to the Azure portal to see the error message if something goes wrong, but I can actually see it in the script as well. We now go back here. Let's see. There is now again a deployment that is running. And we can already see that it has created a couple of resources, and it's now also creating the virtual machine. That one should also happen rather quickly. Yeah, the virtual machine is in place. Now the setup script is also happening, and that will take a couple of seconds. So to show you the result, I have already prepared one. So that deployment has succeeded. If we would wait for, as you can see here, 4 minutes, then the other one should hopefully look the same. And then we will get a message, your deployment is completed. We can take a look at all the different things that have been deployed. If you remember what we saw in the Bicep file, like the public IP address, the data disk, the virtual network, and so on, all those resources have been created, as you can see here. And as an output, we got that script or that connection string that we can use. So if I copy that, go into my PowerShell and log in. Now we are logged into that virtual machine. So again, this is just to give you an idea how we would apply a template and run it. In that case, for a slightly more complex example where we have a virtual machine and some resources around it. Again, this could be something like an Azure function. This could be a C# based service that you're deploying somewhere. This could be a logic app or whatever. So really, there are no limits to what you can deploy using Bicep. If it is an Azure service, then you can deploy it through Bicep. And that makes it very easy to have that infrastructure in place. If you create this for your employees, for your customers or whatever, you always have a very clear idea. You have a very clear overview of what you're deploying, and you can easily recreate your environments if you need to. The last thing that I want to show you is for that particular thing is there is a Bicep visualizer. So you can also get a visual representation, move things around a bit so we can make that a bit bigger. So you can also always take a look at a graphical representation of what you've been creating. So we have the virtual machine, the data disk, the network interface, and so on. So basically the same things we've seen in the file, but now we have it as a visual representation, and that you can, for example, use for your documentation, so people always know what you have deployed, what you have up and running, and what they can use. Okay, so no, I wanted to have the presentation, so that should be this one. Yeah, so what we've seen here is how we can deploy an Azure VM and how we can do this in an Azure Cloud Shell, so we don't have any local dependencies, we don't need to install any tools, only Visual Studio Code, and then we can run this easily. The next thing that I want to show you that has maybe a bit more direct connection to our community is how we can use an Azure Container Instance to deploy Business Central. But again, to help those who've never been in touch with that technology, what is an Azure Container Instance? Azure Container Instances are a managed service that Microsoft is providing to deploy simple container workloads. So if you have, for example, one Business Central container that you want to deploy, you don't want to worry about Docker and VMs and all that stuff. You just want to run one specific container and maybe share it with a customer or give a demo or whatever, then you can use an Azure Container Instance. Compared to a VM, it is a lot faster. It takes care of all the containerization stuff. So if a Docker update is happening or whatever, you don't need to worry about that. And you have very easy access from the internet. So you also don't need to worry about opening ports or having reverse proxies or something like this. But it really is just very easy and open. The only limit we have is that there are only 5 ports for it. The problem is that we can't have resource sharing between containers. So if we create a container instance with 4 CPUs and 16 gigabytes of memories, to give you an example, then those will only be used by that specific container. Whereas if we create a VM with those resources and run multiple containers on it, then those resources can be shared between the containers. So yeah, you just get the resources for one particular instance. And as you're paying per resource, that means that it can become quite costly, for example. And we don't have access to the host. So as Microsoft is managing all the VMs below it and all the Docker stuff and so on, we also don't get direct access, which also, for example, means that we can't use VC Container Helper. But we do have PowerShell to access the container. Again, there's quite good documentation for this one, and I've added the link for this as well. The next topic I actually want to skip because we won't use it in the demo and that doesn't make sense. So what I want to show you in the example is that we will run an Azure Container Instance for Business Central. So we want to just deploy that container to an Azure Container Instance. And again, we will use the Azure Cloud Shell, so we don't have any local dependencies. Basically, we're doing the same thing that we just did, but this time we're not deploying a virtual machine, but instead we are deploying an Azure Container Instance. So for that, I'll go back here and switch to another Bicep file. I can also show you the visualization for that one, but that will be very, very easy because as you can see here, it only has what is called a container group. Basically, that is just one simple container. And to, again, walk you quickly through the different parameters, we have a name for the container. We have a DNS prefix, so we know how we can find it in the internet. We want to use Let's Encrypt for the SSL certificate, so we need to have an email for that. Then we have the generic image that you can see here. We have the artifact that you can see here. In this case, I'm using 19.2 on-prem, but that could also be a different version, of course. We need to give it a username and a password. As you know, when you've created Business Central containers before, we need to let it know how much CPU cores and how much memory we want to give it. And then we can do additional things like custom NAV settings and custom web settings if we want to configure something in the NST or in the web client. We, of course, need to accept the end user license agreement. And there is a suffix and some technical parameters that you typically wouldn't change. And then we, again, have a couple of variables that are created here. And with that, we can create the actual Azure Container Instance. That you can see here. It has a couple of environment variables, which is the way how we let a container know how it is configured. So we basically have our different parameters that you've seen before, like accepting the end user license agreement, the username, the password, and so on. And they are just handed in as parameters to the environment. Then we have the ports that we want to open. As I said, this is limited to 5, so we can't open all the ports that Business Central is potentially using. Instead, I've opened only up those, but you could change that. And then we also need to know that from externally, the same ports are available and what the DNS name label are. And then in the end, we just output something again, which once again, very similar to the example before, is the fully qualified domain name. So with that, we have our definition in place. And let's try again to use that. And for that, I'll upload that definition. Again, and move the file into my folder. And then go back here into my demo description. I'll create a resource group again. And I'll do the actual deployment. Again, some of the parameters I've put in here, you can see, for example, the acceptance of the end user license agreement or the username. But the DNS prefix I want to define myself. And the password I also want to put in directly here. And now it says starting and running. Now, if we go back into the Azure portal again, we see the Areopa BC-ACI resource group that we just created, and we can see here that the deployment is running. You can see that it is deploying. And there you can see that it has created the container instance. Now, if we take a look into the resource group, we can see it here. And the container that is being created. And when it loads, it will probably show waiting. I'll try to reload. There it was, too quick. Try again. Yeah, you can see here status waiting. And the reason for that is that we have that Business Central image that we've shown here. And what needs to happen first is that it needs to download that Business Central image. And because it's a huge one and it takes some time to download and expand, this will take up to 20 minutes. So if you get into that stage and you see waiting here, don't worry, you just need a bit of patience. In the end, it will hopefully show starting, and then you know that it has started after, as I said, around 20 minutes. As we don't want to wait for 20 minutes, I again have an example where it has completed. In the end, it should show something like this, where it says resource is okay. The output is the fully qualified domain name, so I can just easily copy that, put it into a browser window. Oh, and I need to add /BC. And with that, we have it in place. As you can see here, oh no, I need to log in first. Let's see what I used as username and password. I can see that in the container properties. I use Fenster and a super secret password to make sure I don't mistype copying it. And with that, we can log in. So that basically is what we have as option here. As you've seen, it's very easy to just run through that flow and create that container instance. You just need a couple of configuration settings. And if you, for example, want to do this for a couple of customers, maybe for different versions, for a preview version, next major, next minor, or something like this, different language versions, you just need to tweak some parameters, and then you can easily get that infrastructure up and running to share with your customers, with your consultants, or whatever. Again, keep in mind that you're paying for the full resources. So if you create a container instance with two CPU cores and 4 GB of memory, you're basically paying the same price that you would pay for a full VM with 2 CPU cores and 4 GB of memory. So it's not something that you can do for cost saving, and actually it can't share resources. So at the end of the day, it might be more costly, but the benefit is that you don't need to worry about Docker and networking and all that kind of thing. It just automatically works for you. So that is the basic idea of deploying it. Once again, the wrong one. Deploying it through a script. The other thing that we can do is we can use a template and just deploy it through the Azure portal. So behind the scenes, this is using the same scripts and the same things, but we can deploy through the Azure portal, so you don't need to run those scripts and those commands and connect and upload and all that, but instead you're just running it through a GUI. And I want to again show you how that works. first step is to search for the Azure Quick Start templates, and we can find them here. And if we search for BC, there will be only one, as you can see here. And now I can do a deploy to Azure. Let's do that in a new tab because I want to show you the other option in a second as well. I'll log in. And you can see here that I can select the subscription, create a resource group for it, and then basically have all the different parameters that we've seen before in the file. The region, the container group name, the DNS prefix, the email, and so on. So basically all the options we've seen in the file are now here, and I can review and create. But yeah, again, it's not really very user-friendly because I still need to figure out what all those different options are. What we can also do is we can define a file to tweak the UI, and I just want to quickly show you. This is called a create UI definition JSON file, and that one has the different steps here. So we have a basics tab with the name and the DNS prefix and so on, and we can define tooltips here. We can define constraints. This can only have 63 letters. Only specific letters are allowed. For an email, we can put in a regular expression that validates that it's actually an email address and so on. So we can make this a bit more user-friendly. And if we want to try this, go back here. I need to go to GitHub for this. And there we also have a deploy to Azure button, but that one is also using the UI definition file that I've just showed you. So in this case, we are back into the Azure portal, but this time it looks a bit more friendly. We have create a new one. Doesn't really matter, but now we have a bit more in here because we have the tooltips that show the user what is possible. I can't do something like this. It will let me know that this is not a valid email address and so on. And also it hides some of the settings that an end user probably is not familiar with anyways. So I have advanced settings here where I can do more advanced things. And then in the end, I do a review and create. I need to fill in the defaults, otherwise it won't work. So let's just quickly fill them in. You can see here it's also checking that it matches and say accept. And now I can just say review and create. It should hopefully validate. Validation has passed. Click on create again. And now it's doing the exact same thing that we've previously done with the script. It's deploying. The deployment is in progress. Will take 20-25 minutes. And then the Business Central Azure Container Instance is up and running again. So those basically are the two options. You can go full script if you want and run the Bicep commands, or you can go through the Azure portal, as you've seen as well, to give it a more GUI way. But at the same time, behind the scenes, it's using the same template, it's using the same configuration. You always know what is happening. You can version control it, you can go back and so on. So your infrastructure is more secure that way. The last thing that I want to talk about is the other options. So if Bicep, for whatever reason, doesn't work for you, there are a couple of other options. The ones that are most comparable are ARM template, which is Microsoft's original offering, basically solving the same thing, but it's a lot more complex, a lot more difficult to learn and to maintain. Then we have Terraform as an option that is very similar to Bicep, and it additionally has multi-cloud support. So if you want to deploy to Amazon or to Google or to other environments, then Terraform is a very good option because you can handle everything with the same offering. We have Pulumi. That's also interesting because you don't have a descriptive language as we've seen before, but you can use C#, Python, Java, whatever is your favorite programming language to define your infrastructure, which is also a very interesting approach, and it also has multi-cloud support. And then there are others with which you can do similar things, but actually you can do even more. Ansible, Chef, Puppet. If you read those names, then you're in a related infrastructure topic in a related area. So that's it, what I wanted to show you today. Sorry for the problems in the beginning. Not sure where my mouse went, but I hope that this was still interesting for you. You could see how it basically works and find some connection points to your daily business. And as always, if you have questions about it or just want to discuss approaches, feel free to get in touch with me through social media or whatever. I'm always happy to have that kind of discussion.
Thank you, Toby. Very loud and clear. I've got two questions from Torsten. The first one, will linking Azure Key Vaults with Azure Functions and other security configurations work as well with Bicep?
Yes. What you typically would do is that, let's say you create an Azure function and you need that one to access the key vault. That would mean that you would have the key vault also in your template, not that it is created, but just as a reference point. And then you would define the permissions that the Azure function has towards the Azure Key Vault. For example, it can read secrets or maybe even set secrets, depending on what you want to do. But you can include already existing infrastructure, for example, that Azure Key Vault, and then you would add the permissions also in a descriptive way to your Azure function and could deploy it that way.
Thank you very much. Second question from Torsten. Is there a rollback functionality if parts of the deployment with Bicep does not work? And how can existing Azure components, storage accounts, VMs be referenced and used in Bicep?
Yeah, so the existing ones you just reference by name, and Bicep will recognize that they are already there and just use them. For the second part of the question and the first part of the question, how can you do a rollback? Same as we have done a create, you can also do a delete for the resources. So you can delete the resources in one step. Where it gets interesting is if you only want parts of it, so then it becomes a bit more difficult, but you can always kind of revert your deployment and undo the changes. If it has influence on other resources, then that might not fully work. But in our example, where we're just creating an Azure Container Instance or that VM, we can easily just delete the things that we've created.
I hope that's answer enough for it sounds to me like, but I hope
yeah, but,
Torsten,
as I said, feel free to get in touch with your follow-ups as well.
Yeah, he says thank you. So that's loud and clear also. There are no other questions. I had one thought on mind. You have been formerly working at Cosmo, building that offering, that building of DevOps and with environment with containers. Is part of this based upon scripting like this?
Yes. So the backend is set up with exactly scripting like this, a lot more complex. And because we created this at a time where Bicep was not available, we used Terraform. But yeah, basically the full backend can be created not with one simple Terraform file, but actually a bunch of them that are more complex, but it's the same approach. And the reason for that is that if we want to add new environments there, new customers, or we just need new instances or whatever, then we can easily just run one script, same as you've seen here. It takes around half an hour, and then the full infrastructure for that service is also created. But definitely the exact same approach. We want to know what is happening. We want it to be automated. We are running the setup once a week to make sure with an automated test that everything still works and so on. So yeah, absolutely same approach, same tooling, just a different particular tool that we use, but we could use the same or do the same with Bicep, absolutely.
Clear. Thank you. I don't have any other questions, Toby. So yes, you're nicely on time, including the search for a mouse pointer. If, yeah, like you said, if you have any questions, well, anybody should know will succeed to find you. So that will work fine. Let me pick up this part for the closing, because if there are no questions, I think we're ready for today. And thank you very much, Toby. Thank you everybody for being here, and hopefully see you in 2 weeks time, or have you around in 2 weeks time. At that time, Jan Hoek will be the moderator for the session done by Bert Verbeek, because I will have a short leave. So, Toby, thank you very much, and see you later.
Thanks for having me.
More than welcome.